All right, let's talk about graphing straight lines. This should be old hat to you. Like I said, I mean, we did a lot of this in geometry. Okay, we did a ton of this in geometry. So I'm not going to teach this as if you've never seen it before. Okay, we're going to go through it fairly quickly. All right, so because you've had it at least the last 2 years, I would think. Yeah, you probably had some of this in pre-algebra. So maybe the last 3 years. I don't know. All right, here's example 1. I'm just going to start with an example. Actually, let's do this. Before I start with the example, let's talk about this. Let's talk about what an x-intercept is. I'll write out the word for the first time. And talk about what a y-intercept is. Somebody in your own words, without looking in the book or anything, somebody in your own words, just tell me what an x-intercept is and a y-intercept. It's where it does what, Gio? It's not a line, actually. It's actually a point. Yeah, it's the line where, it's the point, you got me saying line now, it's the point where the line crosses the x and the y intercepts. Or the axis, I should say. I shouldn't say intercept there. Axis. All right, so here's a line right there. So where does it cross the x-axis? It crosses it right here. Where does it cross the y-axis? It crosses it right here. So let's just make up a point. So let's say that's at -2, and let's say this is at +2. All right. What is the actual ordered pair for that point right there on the x-axis? It's -2, 0, correct? And what about this one up here? Where is that point? It's 0, +2. Good. So what did you notice? They both have zeros in it, right? All right, so watch this. The x-intercept, where it crosses the x-axis right there, what was equal to 0? The y, right. So the y was equal to 0, okay? Look at this one up here. Which one was the 0 up here? The x. So that means the y-intercept, what was equal to 0? The x is equal to 0. So they're going to ask you to graph something using the x and y-intercept. So for instance, let's do one that they did not put this. Oops. Let me get rid of some stuff here. I should have just drew another graph. It would have been a lot easier, but I'm into it now, so let's keep going. All right, and this, come on. There we go. All right, now we're good. So what if I gave you, guys, come on. It's supposed to be an academic class. So what if I gave you an x and y intercept? What if I said the x, it's not even going to give it to you like that. I'll give it to you as a point. All right. What if I said -3, 0, right? And I said 0, 4. And I asked you to graph the line that has an x-intercept at -3 and a y-intercept at +4. Okay? It's very, very easy. You can't get much easier on this graphing. So you just go to -3, 0. That's your x-intercept. You go to 0, 4, which is your y-intercept. And what do you do with those 2 points? Just connect them. Is there any restrictions on the domain and range and all that kind of stuff? No. It's just all the real numbers. Okay. Is this a function? Yes, it's a function. And there you go. Easiest graph you'll ever do. Would you agree? Yeah, with x and y intercepts, sure. Just 2 points, it's pretty easy to find, connect them, and you got a line. All right? Let's do this. Tell you what, let me, just going to copy that. All right. What about this? You know what? I'm going to use this other graph. Man, I copied it before and I forgot. I recopied something, so I can't paste it. So let's do it again. And there we go. All right, let's give me a nice graph paper thing right here. Rectangular coordinate system. And here's what they're going to ask you to do. They're going to ask you to graph this. 2x, come on, let's write correctly. 2x plus 3y equals 6. But you want to do it with x and y intercepts, okay? I'm not going to write it in here, but it says use, it actually doesn't say it, but in the answer it says they want you to use x and y intercepts. Technically right now, this is the only way you know how to graph anyway, all right? Because all the other stuff, they just expect that you never learned before. But we're going to use x and y intercepts. So let's find the x-intercept and let's find the y-intercept. If I can find those 2 points, it's super easy to graph because what I just finished doing. This time I'm just not giving you the points. You have to figure it out what those points are. So how do I find the x-intercept? What do? I set something. I set y equal to 0, exactly. So let's do that. Let's set y equal to 0. So here's my equation. So what am I going to write? 2x plus, what's 3 times 0? It's just 0. So do I even need the plus? Equals what? 6, x equals 3. So what's my ordered pair? 3, 0. Okay, so that's my x-intercept. Let's do the same thing with the y-intercept. How do I find the y-intercept? I set x equal to 0. Set the other one equal to 0. So let's set this equal to 0. So I get 3y equals 6. Divide by 3. Y is 2. Write it as an ordered pair. X is 0. Y is 2. And now, that's all we had to do to get to where we were before. So it's super easy to graph with the x and y intercepts. I think that's an underrated way to graph. I think a lot of people, especially when it's in a form like this, okay, it's a really nice way to graph. 3, 0, 1, 2, 3, 0, 2, right there. Just connect them, and you got this, and you got this. Does that connect them? Yep, good enough. Put arrows, I'm not going to, and you're good to go. Everybody got that? So that's graphing with the x and y intercept. Yeah, that's good. That's good. Let's do it like that. All right, let's talk about the word slope before we do what you're probably expecting. What are you expecting? What are you expecting to learn how to graph? What form? Do you remember the name of it? Slope-intercept form, right. It's something we talked about a bunch last year. And I'm sure you talked about it in Algebra 2 as well. So we're eventually going to get to that, but let's talk about the word slope. I'm going to run through it quick because you've seen this a million times. What's the first thing that pops in your mind when you think slope? Rise over run. Good. Almost every person would say that, rise over run. But there's another way to write it. Do you remember that? I'll tell you what, let me throw something in there. Let me throw something. Yeah, it's delta y over what? Delta x. What does the delta mean? It's a change in, right. It's the change in y. You'll see this a lot. That's why I want to put it on there. All right, everybody teaches it. Mia came from a different school, and she learned delta y over delta x. We taught it right in here. It's taught everywhere. All right, so what does that mean, the change in something? It means you... Like if I started here at mile marker 3, I ended up at mile marker 7. I changed the distance, right? So how do I figure that out, that change? I do what to it? Change in time, right? So 5 o'clock to 10 o'clock. What is that? What did I do to figure out that change in time? Subtracted, right? So we subtract. Now a lot of books will go y2 minus y1. It does not matter if you go y2 minus y1, as long as you do the x's in the same order, okay? You got to subtract them in the same order. So you could, I'll put or, you could say y1 minus y2. But then what are you going to have to do with the x's? You're going to have to go the first x minus the second x, okay? All right. And you know how to do this on a graph. I'm not getting into all the nitty-gritty of this, but let's say you had a line. I'm not even going to put points on here, okay? Just going to say I got a line right there. And you wanted to find the slope of that line, Okay, everybody looking up here, right? Got heads down. Everybody should be looking up. I say that in CP. I shouldn't have to say that in honors. So here we go. What if there was a point right here and a point right here, and I want to find the slope of it? What do? It's the change in y over the change in x, or I rise and run. You could go from the bottom to the top, or you could go from the top to the bottom. It doesn't make any difference. So what if I go from the top, to the bottom? Okay, this would be my rise, correct? This would be my run. So if these actually go through points where you could see on a graph paper, right, you would just count from here to here, and then you would count from here to here. So if they gave you the graph, they'll probably put it on graph paper, right, like a little square of graph, and then you should be able to just count. What if they don't give it to you like that? What if they give it to you as, let me find a good one. There we go. Example 4 is what I'm looking for. What if they just give you 2 points and they didn't give you the graph? Shouldn't be any problem. Oops, not graph. Find the slope. So what if they ask you to find the slope between these 2 points? I'm not going to graph it and then count on my graph. That would be a waste of time. We can do it much more efficiently, much quicker with what we just talked about. 8, negative 8, 5, and 4, negative 3. Okay? So you're going to find the slope between these 2 points. Well, do you remember what the equation is, or the formula? It's y2 minus y1 over x2 minus x1, or the change in y over the change in x. What does that mean? You just subtract the y values. Which ones are the y's? Well, that's an x and that's a y. We'll call that x1, y1, and that's an x and that's a y. We'll call this x2 and y2. It does not matter what order you subtract the y's in, as long as you subtract the x's in the same order. Okay? So you could go y2 minus y1, which is negative 3 minus 5. Now, if I went y2 minus y1, I have to go 4 minus, is it 4 minus 8? It will be, but 4 minus negative 8. Okay? Everybody with me? Let's get that. That's negative 8. That's 12. That's what? Negative 4 goes into both of them twice, 3 times, negative 2/3. What if I subtracted the other way? Will I get the same slope? All right, yeah. So let's do it this way. Let's go 5 minus what? Negative 3 over negative 8 minus 4. Okay, that's positive 8 divided by negative 12. It's the same exact thing, isn't it? It's still negative 2/3. Notice, you could have the negative on the top, you could have the negative on the bottom, or you put the negative right out front. If I was to write the answer, I think it looks a little nicer just putting the negative right out front like this. Okay, but either way, you get the same exact answer, correct? Do not go y2 minus y1 and then x1 minus x2. The thing that will change will be your sign. Instead of getting a negative 2/3, you'll get a positive 2/3. That's a completely different slope, right? One's this way, one's this way. Okay? All right, enough of that. Let's just do this really quick since we're on this topic. What if I had slope like this? Just looking at that, is that a positive or a negative slope? It's positive because for going left to right, you're going up. What kind of slope is this? Just looking at it. It's a negative slope because going left to right, you're going what? Down. What about this? That's a zero slope. Okay, a horizontal line is a zero slope, which is different than this. This is undefined. Okay, a lot of times we say undefined. You could also say what else? Anybody know? You could also say no slope. It's not solution, but it's no slope. Okay? A lot of people think that no slope is the same thing as zero slope. Okay? Hunter, I think you brought this up at one point. Said that zero is the same thing as nothing. It's not. Zero is different than no slope. All right? Zero is something. Zero is something. All right? It's a number. You can add zero, you can subtract zero, you can multiply by zero. 0 is something. Now, you can't divide by 0, all right, that's true, but you can do all those other things. 0 is something, all right? No slope, 0 slope. What's that?
Why is 0 something?
Because it's on the number line. Anything on the number line is something. We can count with it, right?
But it means nothing.
Does it? No, it doesn't. All right, what else do I want to say? Oh, they even have that in the book. They put that delta. They put that delta thing in there. Let's see. There's stuff in here I can skip.
We should just do it.
All right, they kind of go through honors algebra 2. I probably should have done that, but I'm not going to, just because of the sake of time right now. And we only have one more example, but that's okay. I'm just going to give this to you. They go through the book. If you want to read, they kind of show you how to change it from standard form into slope-intercept form, which we're going to do right here. But we've talked about this so much. You've done it in the last couple years. I'm just going to put it here. So watch. Y equals mx plus b. We've mentioned that several times already today. You got to know what this stuff represents. What is the m in y equals mx plus b? That's the slope. What is the b? It's the y-intercept. I'll just put int. Now, what about this? Somebody in the other class asked me about this x and y. What does that represent? What is it? It's an ordered pair, correct? X, y. This represents any point on the line. Any point. Oops, come on. Any point. Hunter, turn around. You're not completely turned around. Get your shoulders facing the forward because you're just ready to turn around again. I can just tell it. I know the body language. All right, any point on the line this x and y represents. And that's pretty important for what we're going to do from time to time. All right, so they give you an equation and they ask you to graph it. They also ask you to write it in function notation, which is not that big of a deal. Function notation is just taking that y and making it what? F of x, correct. All right, so the function notation is not that hard. It's just graphing this thing. 3x. Now you could, well, let's see. They want you to use slope-intercept form because they say use its slope and its y-intercept. So that's slope-intercept form. So it's 3x plus 2y equals 8. All right? Shouldn't be that hard for you. You might have been able to just walk in this room today without me ever saying anything about this and be able to graph this. Do you think you would? Yeah, you should. You should be able to with the experience that you've had the last couple years. So what I'm going to do is I want to do this by slope-intercept form. So what is slope-intercept form? It's y equals mx plus b. So really, what do I want to do? I want to take this and solve for what? Solve for y. That's why I circled it. Okay, solve for y. Get y by itself. Okay, so if I want to get y by itself, what do I want to get rid of? Well, not just the x, the 3x, and the what? And the 2. Which one am I going to get rid of first? The 3x. So how do I get rid of it? What do I do? Subtract. That's right, because I'm getting rid of that whole thing. Not just the 3. I'm getting rid of that whole thing. What's that whole thing doing to that 2y? It's being added. So how do I get rid of it? I subtract it. Okay? Now, watch what I'm going to do. Since I got this thing, I can just scooch it over. Everybody see that? And I'm going to put it in between. Negative 3x, I'm going to put a plus. Why did I do that? Why didn't I just put 8 minus 3x? Because look at this. The x, the mx, is before the y-intercept. Everybody see that? That's why I put it in there. I slid it right in between. All right, so let's see what we got. That cancels. Bring that down. That's 2y equals, oh, come on, negative 3x plus 8. One more step. Divide by 2. Divide by 2. All right, so y equals negative 3 halves x plus 4. My thing could write. Writing too fast. So that, it's not my answer. I'm going to put it in a box. It's not my answer, but that's what I want to graph. Okay? Because the question says to use the slope and the y-intercept to graph. That's the slope-intercept form. So I put it in the slope-intercept form, and I put a graph, big old graph right there. Okay, and now let's graph it. It should be pretty easy to graph, especially in this form. The y-intercept is 4, so I count up 4. 1, 2, 3, 4. Put a point. Slope is -3/2. Now, with a negative, look, you could look at it like this. You could look at it as -3/2, or you could look at it as 3/2. It doesn't matter. All right, let's do it the first way. So it's rise over run. -3, rise, down 3, 1, 2, 3, 2 run right there. Or if you wanted to, you could go up 3, 1, 2, 3. You could go to the left 2 right there. And look, it all lies on the same line. Right there and right there. We'll extend it out beyond the graph. And there's your graph, and that's all they want you to do. Does that make sense? Yeah, it's not too hard, is it? Pretty simple stuff. But it's going to get harder as we go on, all right? We're not just going to do straight lines. You know the stuff where we had to find the function, if it's a function or not, with all those curvy things? We're going to be doing a lot of that stuff. We're going to actually be graphing those things, okay? They threw it in there just to get used to it. So you look at it and, oh yeah, I've seen that before. All right, but we're actually going to graph that stuff later on, okay? Even that little oval, that ellipse thing, we're going to graph that. The thing that gets really close to the x-axis but never touches, we're going to graph that. Okay, a lot of stuff. It's on the lesson plan. It's on the lesson plan. I gave it to you yesterday. You're supposed to, that's why I give it to you. That's why I give it to you. So, what is the homework, since you're asking? Section 2.2. Is it 2.2? Yep. Yep. There's no A or B on this one, so it's section 2.2. It's pages 66 and 67. Don't know why I'm doing this again, mainly just for YouTube. And then 1 to 37 odd. All right, so you're only doing the odds. So tomorrow I'm not going to read off the answers because they're all odds, so you should check to see if you're getting them right. Don't just look in the back and then write down the answer and then turn it in. All right, that's ridiculous. So make sure you do it. See if you got it right. If you got it right, cool. Go on to the next one. You know the deal. Everybody good? All right.